Dear students of Greenland Public School, Shivdhara, good morning. Dear students of class 10th, I would like to guide you again in chapter physics, in electricity chapter in physics, and perhaps it is 10th class, page number 20. I have written over here. Up to here we have read about resistance and resistivity. So there are many applications of resistance and resistivity in heating elements like toasters, like heating water heater, iron, etc. And they are mostly made of an alloy. Then question arises over here. At first I would like to say the heating elements or heating coils of electrical heating appliances such as electric iron and toasters etc. are made of an alloy rather than a pure metal. Why? Because nichrome has very high resistivity which produces a lot of heat on passing current, and this heat causes the heating effect more and more. That is why nichrome is used in heating elements like in electric heater. So nichrome has very high resistivity which produces a lot of heat on passing current. Another reason is that nichrome does not undergo oxidation or burn easily even at high temperature. Nichrome does not undergo oxidation or burn easily even at high temperature. This is why nichrome wire is used in heating elements. Now question is over here. A copper wire has a diameter of 0.5 millimeter. A copper wire has a diameter of 0.5 millimeter and resistivity of 1.6 into 10 inverse 8 ohm meter. A copper wire has a diameter of 0.5 millimeter and resistivity of 1.6 into 10 inverse 8 ohm meter. The student's question is given here, and the diameter of the copper wire is 0.5 millimeter and resistivity is 1.6 into 10 inverse 8 ohm meter. Now there are two questions over here. What will be the length of this wire to make a resistance of 10 ohm? What will be the length of this wire to make its resistance 10 ohm? Another, how much does the resistance change if the diameter is doubled? Dear students, in first condition what is given here? Diameter of the wire is given 0.5 millimeter. We have to find out radius and we have to convert it into meter. Here resistivity is given 1.6 into 10 inverse 8 ohm meter, and resistance we have to bring 10 ohm. So we have to find out length. It is meant here, since resistance is equal to rho into L upon A, that is resistivity into length upon area. So we can say this length is equal to resistance into area upon resistivity. So length is equal to resistance into area upon resistivity. Now here resistance we have to bring 10 ohm and resistivity is given 1.6 into 10 inverse 8 ohm meter. Now we have to find out area. What will be area? Dear students, for area we have to find out radius. Since diameter is given 0.5 millimeter is equal to 5 by 10 millimeter is equal to 5 by 100 centimeter is equal to 1 by 20 centimeter. So 1 by 20 centimeter is diameter and radius will be half of diameter. So radius is equal to 1 by 2 into 1 by 20, that is 1 by 40 centimeter is equal to 1 by 40 into 100 meter is equal to 1 by 4000 meter. 1 by 4000 meter, that is radius. So we can say here area is equal to pi r square. So pi into 1 by 4000 square is equal to 22 upon 7 into 4 4 just 16, and here 3 zeros. So we have to, and it is a square, so we have to put here 6 0 1 2 3 4 5 6. Now 22 upon 7 into 1 by 16 into 10 to the power 6, because 6 zeros, that is why here now area is equal to pi r square. So we have got pi r square, that is 22 upon 7 into 1 by 16 into 10 to the power 6 meter square. Dear students, again length we have to find out. Length is equal to resistance into area upon resistivity. Resistance we have to bring 10 and area we have got 22 upon 7 into 1 by 16 into 10 to the power 6, and resistivity is given in the question 1.6 into 10 inverse 8 meter. So 1 by 1.6 into 10 inverse 8. Now we can do this calculation over here. This is 22, so I have written 22. 7 into 16, 7 into 16 into this 10 over here. Now this 10 to the power 6 will become 10 to the power minus 6 if it goes up. 10 to the power minus 6 into this 10 to the power minus 8 will become 10 to the power 8. Here 1.6, it is 1.6. In next line I have written 22. This is 22. Again this is 10, this is 10. And if you remove this decimal from here, you can write 10 more. So that is 22 into 10 into 10 upon 7 into 16. Now 1.6 has become 16 into. Now here 10 to the power 8 and 10 to the power minus 6. So 10 to the power minus 6 plus 8. 10 to the power minus 6 plus 8. Now here 22 into this 10 into 10 can be written a square up 10 square upon 7 into 16 into 10 to the power 8 minus 6 is equal to, now 2 11 ja I have crossed and 2 8 ja. So 11 upon 7 into 8 into 16 we have got 896 into 10 to the power 2 into 10 to the power 2 meter is equal to, if I divide 11 by 896 we get here 0 decimal 01227 into, now 10 to the power 2 into 4. So we can say here after 4 decimal you have to carry 4 digits towards right. So 1 2 3 4, that is we get here 122.7 meter. So we can say here length of wire we have got 122.7. Now here second part is given, that how much does the resistance change if the diameter is doubled. The resistance depends upon cross section area. So if diameter is doubled, it means radius will also be doubled, and if radius becomes double, then we can say here resistance square of area will be pi r square. It means if it becomes double, then square of double will be 1 by 4 times. So according to that, resistance will become 1 by 4 times. You will try yourself now. You have followed this topic again. Now I would like to give one more question to you all. You will try to do a 6 ohm resistance. A 6 ohm resistance wire is doubled up by folding. You will see again, a 6 ohm resistance wire is doubled up by folding. Calculate the new resistance of the wire. You have to find out the new resistance. What will be the new resistance? And this has been folded. So you will try to do yourself. A little bit hint I am giving. Since R is equal to, what happens? R is equal to rho into L upon A. Or here it is given 6 ohm. In this condition 6 ohm. So we can write here 6 is equal to rho into L upon A. Now it is given that this wire is doubled up by folding. So it means length will become half and area will become double. If this time length will become half and area will become double, so new resistance, so new, at first you write new length is equal to here we can write here L upon 2, and new area is equal to, we can write here A upon A. Now area will increase, so it will become double then. Therefore new resistance R is equal to rho into L. In place of L we can write L upon 2, and in place of area we can write 2A. So we can say here rho, it means we can say here 2 to 4, so 1 by 4 into rho into L upon A is equal to, now 1 upon 4 into here rho into L upon A. From here rho into L upon A is given 6, so we can write here 1.5 ohm. Thank you.